Blender 3.4 contains a significant new sampling technology for the Cycles render engine called path guiding. Path guiding is an important sampling technology for indirect illumination that's been developed to help improve noise convergence by finding areas of bright indirect illumination and then sampling those areas more efficiently. Ray tracing is a backwards process where rays fire from the camera and back into the scene, where they then scatter around, gathering light information from every intersection. If a brightly lit part of the scene happens to be sampled by a ray tracing ray, but very few other rays strike that area, it can cause what's called a firefly, or it can just create a lot of noise that can take a long time to clear up. Path guiding sees these areas via a training or learning process and then helps the renderer to concentrate rays along similar pathways that have been noted to return higher light values and then to sample those areas more aggressively. In other words, path guiding helps the renderer to know what areas to sample more and what areas to sample less. That is, to importance sample the scene. So the path guiding mechanism helps in two ways. One is through the more efficient overall sampling, which helps to reduce noise more quickly than standard sampling. And the second is to help transport light through refractive dielectric surfaces, meaning glass or liquids. This can be seen as light passing through glass window in an architectural scene, or as caustics appearing through glass objects. This has been a challenge for Cycles. So let's take a look at this. The first thing to note is that path guiding is only enabled for the CPU right now in this first release. The developers have stated that they're probably going to end up doing GPU once this initial release has been shaken down and any issues that have been shown up can be fixed. So for now, in order to see the path guiding option to enable it in the sampling region, you have to come in and go to CPU only, and then you can see the path guiding function become enabled. Let's go ahead and turn Cycles on here, the preview, and we'll just see it without path guiding. And the thing to note is that I've got some glass right here, like architectural glass. It's just a standard glass material, but previously in Cycles, if you wanted the light, in this case I'm using an HDRI light, you wanted a very strong sunspot in that HDRI to come through, you would basically have to just disable that piece of glass and just not have it there. And that may work under some situations, but sometimes having that glass is nice because it's actually going to reflect part of the scene. So we'll come back in and turn it on, and you can see that currently we don't get that strong light source coming through. But as soon as we turn on path guiding, it's going to start processing, and you're not initially going to see anything. It is a process of learning where bright light sources are, and as soon as it starts getting rays that hit that, it starts concentrating rays in those directions. And look at that, you begin to see that light from the HDRI image, which is an indirect light source. That's what path guiding is essentially doing. It's optimizing indirect light sources, and it's coming through the window. So the other thing to note is that path guiding currently is limited to surfaces that have a diffuse component, and that's important to remember. It doesn't affect the glossy reflections. That is another thing the developers have stated is on sort of the docket to implement. So that's pretty cool. The path guiding function doesn't have very many options, and typically you can just turn it on and go. The training samples is the only thing you may end up adjusting, and that's the number of samples that use the path guiding operation, meaning the first 128 samples of a rendering will use this path guiding algorithm to determine if those particular rays are striking surfaces that need more attention. Once you get to 129 samples, the path guiding operation no longer functions, and it simply uses the importance map, if you want to think about it that way, from those first 128 rays to continue importance sample the rest of the scene. So those first 128 rays are going to be a little bit slower than without path guiding. But in the long haul, the data gathered by those 128 rays will actually improve the performance of the rendering. So let's take a look at some other examples, and we can look at this in an example-based way. We're going to take one example here from this dining room scene. On the left side is the noise-reduced path guiding version, and the right side is the original rendering that did not contain path guiding. And you can clearly see back here there's more noise as compared to this side. These were both rendered to the same amount of time. I think it was, I don't know, maybe 10 minutes. So that's the great thing, is it can get you to a place where you can use noise reduction more quickly. The thing to remember, you can't use GPU right now. So depending on what you're going to be rendering, GPU rendering using the standard sampling still may be faster. So consider this to be sort of almost a technology preview, but we're going to get to some situations where GPU rendering just can't do what path guiding is going to allow you to do. So let's take a look at another example. On the left side is the original type of sampling, and on the right side is the path-guided version. Both were rendered to the same amount of time. Clearly, if you look at this mug, this has quite a bit less noise than this does over here. Let's take a look at another example. Here on the left side is the non-path-guided version, and the right side is with the path-guided version. And it clearly has less noise given the same amount of time. Let's take a look at another interesting image where I'm going to show you the version entirely without any path guiding. This is just cycles, standard sampling, and now we're going to look at it with path guiding turned on. And you can clearly see in some areas, the couch on the right, for instance, has quite a bit less noise. The coffee table has less noise. The brick has less noise, given the same amount of time. Now, in this particular case, in order to get the light coming through, I disabled the glass on the windows so that the light would come through the same for both of them. But what we're going to do now is we're going to take a look at some really interesting examples of what happens when you do have glass, or more technically dielectrics, in a scene. Now what we're going to do is we're going to take a look at how path guiding can improve light coming through dielectric surfaces, or glass types of surfaces, transparent surfaces, anytime the material is transmissive. In 3.3, it really kind of struggled with that. But let's remind ourselves how it is that we get caustics in Blender. When we come over to light paths for cycles, you have to come down to the light paths area, and you need to remember to turn filter glossy to 0. And for transmissive caustics in particular, we want to set indirect to something higher than 10. And what's going to happen is now with path guiding, you can really effectively turn this value up to higher values. So I typically have found now that a value of 20 or 25 works better with path guiding. So let's take a look at some examples. So if I come over and let's turn off path guiding, and we'll just turn on this rendering, we get just shadows. And we get a little bit of the caustics slowly resolving, but it's very grainy and it's very noisy, and it's going to take a while to get them, if at all. But as soon as I come over here and turn path guiding on, give it a second, look at that. Look at how we're suddenly getting that light naturally passing through the glass. So let's take a look at some pre-rendered examples. So here's an example rendered in cycles 3.3. Given the same amount of time, if you turn on path guiding, you would get this. It's fantastic. It cleans up so much more efficiently. Let's take a look at another example. Here's one where I've thrown a few other objects in, gave it a certain amount of time to render, and it was struggling. It was kind of getting some of the caustics, but it's mostly just fireflies and noise. And what happens is the path guiding system sees some of these successful traces at finding the light source, and it says, oh, there's a light source. I'm going to remember that. And it's going to start trying to cast more rays along the path, or along a very similar path, thinking it'll be able to strike whatever that light source is. And then we get this. Isn't that amazing, the difference with path guiding given the same amount of time? And this is without noise reduction. I did not want to turn noise reduction on because I wanted you to be able to see the grain patterns. So let's take a look at another example. Here's one without path guiding. As soon as I turn path guiding on, then we get that. Given, again, same amount of time for both of them. Let's take a look at another example. This is a really good example, in fact. We have a gold clock right here, and the gold clock has the face, but in front of the face is a glass covering. So if I turn that off, you can see the clock face and then the gold covering. And when we enable rendering with an HDRI image, we're missing light hitting the clock face. the light rays passing through that refractive surface get refracted and tossed off in all directions, and they're not really hitting that bright sunspot of the HDRI image. But as soon as we come in and turn path guiding on, watch what happens. Do you see how it starts finding that path to the light source that allows it to pass through the glass and illuminate that surface? Fantastic. So let's take a look at some pre-rendered versions of this. So here it is with path guiding turned off. The light is struggling to get through the glass. As soon as we turn path guiding on, given the same amount of time, we get that. Look how it's able to clean that up through that glass material. Let's look at one more example. Here it is without, and here it is with path guiding, given the same amount of time. It's amazing. Here's a great example of an architectural scene. This was rendered without path guiding, and I actually have proper glass in the glass windows. And this is something where I'm just using an HDRI image of an exterior scene. Frequently those would catch the sun, and the sun would naturally cast a strong light source through the scene. But without path guiding, we're not seeing that. So as soon as I turn on the path guided version, that is what we get. And you can clearly see that bright light coming through from the sun, but there's also a little bit more light in general in the scene. So without path guiding, we're actually losing a fair amount of light energy. So let's take a look at a couple of other examples. So here is a scene of another interior where we have proper architectural glass. And I like this because in this glass over here, you can actually see a reflection of the light source right here. So as soon as we turn on the properly path-guided version, then we get that. The sunlight from the HDRI image is properly coming through the glass because of the path guiding process. And it just looks so much better. And we're also getting a little bit more noise reduction because of that. Let's take a look at a particularly interesting example. I have a bathroom, this scene that I built, and I, again, have proper architectural glass. Now, you could say, why don't you just turn off the glass if we're not going to see it? But in this particular case, I have glass doors. And those glass doors you would expect to see light passing through if you have a strong external light source. So if I turn on the path-guided version, this is what we get. And look at that. It's brighter because now so much more energy is getting into the scene because of the path guiding process. But in particular, we can clearly see that direct light source from the HDRI image, which is the sun, coming through not only the glass in the walls, but also the glass of the shower door. Let's take a look at another example of this. Here's the same scene without path guiding, and now with path guiding. And in this particular case, I closed the doors entirely. We now still get proper light coming from the HDRI's captured sun, passing through both the glass here and the glass into the shower. And it's awesome. Here is another fantastic example. This mint scene that I've used in another tutorial, there's a clear plastic covering over the mints, and the light struggles to get through there. There's a strong light source casting a directional light, and as soon as I turn path guiding on, give it a second as it figures out those light paths, and you can clearly see the light coming in. Let's take a look at this in final rendered form. Here it is without path guiding, and now here it is with path guiding. It just makes all the difference how that cleans up and it looks more realistic. Let's take a look at some caustic examples. So let's take a look at an example here of just a very generic type of caustic scene where we've got these curved metal bars and we've got this ring. Given just a couple of minutes of rendering, we can see that there are clearly focused lights. They're really grainy and it's going to take a while to render and to get this. But as soon as we turn on path guiding and give it exactly the same amount of time that this had to render, then we get that. We get much cleaner caustics. And I think this was only maybe a 2 or 3 minute render. Let's take a look at a really fantastic example. Here is a soap dispenser type of object rendered in 3.3, and you can see that there are some caustics down here, but they're kind of ephemeral given how bright the light source is. We have an HDRI image with the sun source in it, but as soon as we turn on path guiding, then you get this. Look at that. That's what path guiding did given the same amount of time. Isn't that amazing? Now, you'll have to play with these because every scene is going to be a little bit different as to how it responds, and every object is going to be a little bit different with how it responds. But the thing to remember is that for Caustics to appear, the receiving surface has to have a diffuse component. That's the key. The developers have stated that they plan to implement path guiding into the glossy mechanism at some point in the future. That's on their plans list. And then we'll look at a couple of other examples of a little perfume bottle. So this is with 3.3, and I didn't turn on noise reduction, and I let these render for just maybe 3 or 4 minutes. And then as soon as we turn the path guiding version on, you can see how much more intense and bright the caustics get, because the path guiding mechanism helps the ray tracer to see where those bright light source paths are through the refracted glass and capture them. Okay, and then we can do one more example. Here's a really particularly good example. This is rendered with 3.3 without path guiding, and I rendered it for, I don't know, I think it was maybe 300 samples. And then I rendered a version with path guiding with the same number of samples, and that's what you get. So path guiding clearly improves this image and samples those caustics quite a bit better.